Welcome to Study Loop.
All right, here's a cool problem. We have two cards held together by a 39-foot long rope, and the left card's moving to the left at 2 feet per second, and we want to find out at the position that the card is 5 feet away from the center, basically what is the rate that card B is moving toward Q, which is basically the center position here. So a pretty cool problem. All right, so let's start off by just looking at card A to kind of analyze what's happening here. So card A, notice that as it goes to the left, we form a right triangle. You know the height is 12 feet, and in general, his position is XA. And so if we were to do a Pythagorean theorem, we'd say XA squared plus 12 squared equals, let's call this length A. That's the length that's currently on the side of card A, equals length A squared. I can take the derivative of both sides. That will give me 2XA dx dt. I'll call it dxa dt, plus 0 equals twice the length of the string dla dt, because that can change with time. Okay, we can divide through by 2, and that gives us then our rate of change of length of the rope is equal to xa over la, and then dxa dt. Well, we can find that specific value based on the information we've been given. You know, XA is 5 feet at the point of interest. LA is when X is 5, we have a 5, 12, 13, a special triangle. You could do Pythagorean theorem, but it's not that hard to see that our length is actually going to be then 13 as our hypotenuse, 13 feet. And then we are told we are traveling at 2 feet per second. So therefore, we are getting 10 over 13. That is our rate of change of length of the rope with time. And I'm focusing on the rope because the rope is the one thing that connects both cart A and cart B. So now we can go over and take a look at what's happening with cart B, because ultimately we want to know how fast cart B is moving towards Q. Okay, so same idea. If I were to draw a right triangle that kind of looks more this way, then I have this length. The hypotenuse is now 39 minus LA. We still have a height of 12 feet, and I'll call the distance away from Q XB. Okay, so at this moment, we know LA is 13. So if we subtract 39 minus 13, that gives us 26. So the current length of the string is 26. So I can find XB at the moment by Pythagorean theorem. So XB is square root of 26 squared minus 12 squared. And that turns out to be 532 in the square root. So it doesn't clean up nice. So there it is. XB is root 532, and that would be in feet. Okay, like before, we can set up our Pythagorean theorem. XB squared plus 12 feet, that one should have been squared before anyway, and squared now, equals LB squared. So we take a derivative, we get, let's change color to back, just get a different color going. That will be twice XB dxb dt. Remember, that's what we want. We want this dxb dt. That will be our final answer. The constant derivative is 0. And then we'll get twice LB times dlb dt. Okay, so now we can divide through by 2s like we did before, and really we want dxb dt, and that will be equal to lb over xb dlb dt. Let's see if we have room to squish in values here. Okay, so LB we know is equal to 26 feet over XB. XB is currently square root of 532 feet. So we get feet over feet. And dLBdt, it's going to be the same rate of change, just only get it shrinking. So I get minus 1013 feet per second. So we can clean that up just a tad. It turns out, 26 divided by 13 is 2, so I ended up with minus 20. I put way up top here. So the final answer for the rate of change of cart B with time, we're going to do absolute value since we're just doing how fast. So that will give me 20 over square root of 532 feet per second, and we did it. Yay. All right, hopefully that helped. Have an amazing day and see you next time.